Hello and welcome to this today being day 4 of this EDSA CAD training, and this is GIS. We are quickly going to look at our code for today. The more that you read, the more things you will know. The more that you learn, the more places you will go. Education is the most powerful weapon which you can use to change the world. And lastly, study the past if you want to intuit the future. These Chinese people are making sense with a lot of their project, their codes and their proverbs and all that. So we've done ArcGIS basis, we've done geodata based on shapefile, and I believe most of you guys did the assignment I gave you and most didn't. So we are at Geo-referencing now. So let's see how far we can go. But before we get into the practical session, let's look at what georeferencing is. So georeferencing is the process of making digital image, of taking a digital image, It could be an air photo, it could be an auto photo, it could be a scanned geologic map, it could be a picture of a topographic map, and then we add geographic information to that image so that GIS or mapping software can place the image in its appropriate real-world location. This process is completed by selecting pixels in the digital image and assigning them geographic coordinates. In rare instances, one may already know the geographic coordinates of certain pixels in an image. More frequently, a non-georeferenced image is georeferenced to an existing image that already has embedded geographic information. Georeferencing is that process of aligning digital data, like the maps or image, to a known coordinate system, allowing them to be viewed, queried, and analyzed with other geographic data in their real-world location. So how does this georeferencing work? Basically, we identify control points. So select known points on the digital data, corners of a map, intersection on an aerial photo, and their corresponding real-world coordinates. Then transform the data. Use those control points to perform coordinate transformation, shifting, rotating, scaling, skewing, or wrapping to align the digital data with real-world coordinates. Things to note: so you can georeference a raster to either another raster or a raster to a future class or a shapefile. When you have a raster that is georeferenced, you can use it to georeference another raster that is not georeferenced, or you can use a raster that is not georeferenced of that same location with a shapefile or a future class which is georeferenced. All right. So while georeference, look for well-defined objects in your images, such as road, intersections, or land features. These objects should be on the ground and should not be elevated features, like elevation, that's what I mean. This way, you can be certain that you are referencing the same location in both raster and aligned layers. And secondly, or thirdly, you export your control point before you close the project. This way we start the class, you will understand basically. So this is what we are covering, the practical session now. How to georeference using shapefile, how to georeference using coordinates, and how to georeference using Google Earth. Alright, so these are how we are going to go about this. But I think for this video we may be doing only two. but let's see how we go. But we'll start with georeferenced, how to georeference using coordinates. All right. So with your ArcGIS launched, let's go in for some fun. So we will click on add data, and I believe each of you has received the image that was shared. So topo sheet JPEG. So you just bring it in. So once it enter, let's see, it's like there are some kind of georeferencing point here. So let's remove this. Okay. So you will see your image this way, right? So, the class recording was corrupted, so I'm going to recreate this. I don't know if this will, because we did quite a number of things, so I'm going to recreate this. So the image is inverted like this. That's how you will see it. All right. So what we discussed in class was right click, zoom to extend. So you're going to look at that the image has lines, both vertical and horizontal. So let's zoom it here. Okay. So let's come. So we have our 9.40, that 9 degrees 40 minutes on the north, and 9 minutes 00 minutes on the east. So we will be following this one here second, because there is an intersection. So we have 9 degrees 30 seconds. So let's move until we find a vertical intersection, which is this. It's also another 9 degrees 30 minutes. So if you have your georeferencing tool like mine here, if you don't have it, just right click and you're going to see georeferencing tool. So you click on this, make sure that it's showing this topo sheet. All right. So you click on this add control point. So on this intersection, you click on it. Now you right click. Most of you, your image is not showing, like when you right click on this control point, your own is only showing input X and Y. That is understandable. Mine is showing both. Now what you need to do is just go with the one that is activated. You click on it, X and Y. Now your X is your eastern, your Y is your northern. Your X is your longitude, your Y is your latitude. Okay. Now we need to convert this. All right. Now to convert this, you quickly just grab your internet. Just go to internet, then you go to your browser. All right. So I'm going to connect my system to internet now, and then I'm going to browser. So my system is connected. So I'm just going to go to any browser. All right. Then I'm going to search for coordinate converter. Okay. So let's check quite a number of them, because we don't know which one will work and which one will not work. I'm just going to grab anyone I see, longitude and latitude conversion, so that when we try it, okay. So all right, so we have this to give us this. Now I don't even understand what let's check this one. Okay, so we have degree, minutes, seconds to give us longitude and latitude. Good. So I think this one will work. fcc.gov. Just go to fcc.gov/media. I'm going to drop the link at the end of the video, the description. I'm going to send it to your group as well. So we have 9 degrees 30 seconds. So I'm just going to bring my online keyboard, my on-screen keyboard, because I have an issue with my. So we have 9 degrees 30 minutes 0.1 seconds or 0.0 seconds, anyone. Then we also have 9 degrees. This is on the latitude, don't forget. 9 degrees 30 seconds, 0 minute, 0 seconds. All right, so now you click on converting it. So we have 9.5, 9.5. So you either put the 9.5, 9.5 or 9.500 27770 sorry. So now I'm just showing how you can convert this, and then if you have decimal degree you want to convert it to latitude, you can also do that. So this converter is enough for you. So what we'll do is that we're going to go back. I'm just going to copy this. Since I'm having issue now, I just copy this. Now let's go back to our ArcGIS. So now here I'm going to put 9.5. Here I'm going to put 9.5. That is if I want to summarize it, but ideally it's supposed to be 0027778. Okay, so same thing here, 00, because they are both 930, 930, 2777778. So you click on OK. Now once you click on OK, it will disappear. So you right click on this and then you click on zoom to layer. You see it's come back, but it's not changing anything. But I believe, but now it's responding to scale more than before. All right, so it's responding to scale because we are already adding scale to it. I don't know, sorry. So we zoom this at this place and then we drag it. So now we have another point here, which is 9 on the north now, 9:30, 9 degree 30 seconds. So we go to find another intersection. All right, so we keep going, we keep going, we keep going. So we see another intersection at 11:30 on the east. 11 is on the east, and so we zoom this very well, and then we click left click, then we right click, input. Now on our Y here we already have 9.5 or 900277778, right? Now we need to convert the 11, which we already know is going to be 11. So let's just drop this. So it's for conversion, it's 1100277778. But let's go back and try converting it so that we see if. So this is what we have, right? So click on convert. You see 11.5, 9.5. So now I just did that so that you see the verification. So click on OK. So you right click, zoom to layer. You see that your image, by the time you put these 2 points, your image has come back inverted like this. So we have 2 more points to go, and we're going in a clockwise direction. So we go like this. Okay, so now we're going to zoom it down here. So when we zoom to this place, we see that we have 11.30. So we just go up to get, either we come up to this 7.00 or we use the down one, but let's use this 7.00. So so we see an intersection, the second, so click, then we'll right click and we come to this. So our easting is already giving us 11.5. So we'll just add 27778. All right, now our 6 now is 7, but let's go and convert and see. Okay, so let's go back and then we just put 700. So we click on convert. So it just gives us 7. So we're just going to have 7 on it. Okay, so we go back and we make it 7, and then we click on OK. All right, so you see that this third point now, it didn't make it shift. It didn't make it disappear. It just shift. All right, so just making an adjustment. So we can either use the one of 6 or we still use the 7. So this is, what is this now here? This is 9:30, which we already have it. So when we draw up to 7, so we just draw this. So this 7 is at what now? Let's be sure. 7 is at what now? 7 is at, let's go down so that we don't make mistake. Okay, so this is at the east and this is at the north, all right? So 7 is on the northern axis, okay? So we zoom this and we click. This will be our 4th point, and we right click. Then we come to X, Y again. So this will be our 9. So 9500277778. And then we have only 7, right? That was what we did there. And then we click on OK. So you see that it's just making a shift from one of the point to another. So so once we have this done, we have our 4 points, which you can see point 1, point 2, point 3, point 4 clockwise. All right. Now the next thing we want to do is to come to this georeferencing, but you're using this drop down button that you're seeing here. If you click on this or you click on the drop down button, it's going to bring this up. So what we want to do is to rectify this image. All right, so you click on it. So here you just make a selection to the folder to which the work should be. So we're going to put it on Taraba. So I'm just going to click on Taraba, or let's put it on ABU Zaria. Just click on ABU Zaria and click on add. Now we can just leave the name here the way it is. Then this format, it's TIF. So we'll leave it like that. If they ask for compression, we want to be JPEG, so anyone you can leave it, but then you click on save. Now this is going to read from 0 to 100. Okay, so we can see that it is done, but those 4 points are still there. Yeah, you come back, click here, and then you click on update georeferencing. So you see your georeferencing has been updated. So you just click on this arrow here, select element, and everything is done. Okay, but now we make mention of something while we were having the theoretical class. We mentioned export your control points before you close the project. Yes, so that's what we want to do now. So to export our control points, we come down. If you under this georeferencing, if you follow this place down, you will see viewers and you also see view link table. So click on the view link table. Now you're going to see 4 control points. We make selection. You see them. Now why they want you to these are our x and y coordinates of it, the source. Now you see our coordinate is 9 point this. These are the x source, y source, yeah, but these are the coordinates we imputed. We have 9.50.02778. Same thing here. These are the coordinates we've imputed for x and for y, which we can see. These are exact things we've imputed, yeah? Now let's come to looking at our residual of x. Also, this minus 0.0396599. Same thing as 0.0039 like that of the x of all of these. Same thing as the residual of y. Now the residual of this and this will give us 0.004, which means our georeferencing is moving well, right? So you can export this by just hitting on the save button and then export it. Let's say we can just say residual, and then we click on save. So our residual here, our control points have been saved. Now this can be used as reference point. You can also screenshot it for all that. So you can see that our total RMS, our residual mean error, is this what we have here, which our georeferencing is good. So you should minimize those error by trying this point I did. Please take your time and go through this whole update it again, and then you see that it is done. So basically this is how we can georeference using the coordinate, because most of the times those maps has coordinate on it. Now tomorrow we'll be looking at the instances whereby there is no coordinate on this map and we want to georeference it. So that will bring us to where we're using shapefile. So please try and get this so that tomorrow we can go ahead into doing the second version of this georeferencing. Please take advantage of this training. Most people will not really sit down to teach you this. They will just quickly move and just show you one or two things, georeference, and they are gone. I'm taking my time to explain this thing for you guys, not because of anything, but because I want you to know. Please, the ball is in your court to take advantage of this or to leave it. All right, so I've done my part, and it is now left for you to do your own part. All right, but before we go, let's look at our usual code. There is no elevator to success. You have to take the stairs. There's no two way about it. There's just no two way about it. You just have to take the stairs. If you want to succeed in this, you have to take the stairs. You have to follow the procedure. Step 1, step 2, step 3, step 4. Journey of 1,000 miles begins with what? A step. So now that step you need to take for this training. Okay? So great things are done by a series of small things brought together. This little, the way you see with the do am like that, the do and the play, the do and the play. When you accumulate them, it gives you great things. So please take advantage of this. I will see you tomorrow by 1 p.m. Alright, this video was summarized based on I had to redo it because of the class own was corrupted. You know how we've been posting and going on to just make sure we understand all of this. So I believe this is a more summarized video of the class. So thank you. I'll see you tomorrow.